Hi everyone, today I'm going to teach you how geometry is used in the medical field, specifically sonography. While ultrasounds may look and seem simple, it's actually kind of complicated because geometry is involved in every single scan sonographers perform. My math topic is going to focus on the three anatomical planes, sagittal, transverse, and coronal, and how 2D ultrasound slices relate to 3D anatomy of the body. So what are anatomical planes? They're basically a 2D geometric slice through the 3D body, so taking a solid object and dividing it with a plane. A sagittal plane cuts the body into left and right sections. In ultrasound, this is a long axis view, and we see structures stretched out lengthwise, like the spine or kidney. A transverse plane divides the body into upper and lower parts. In this view, organs often look round or oval because we are slicing across them. A coronal plane divides the body into front and back sections. It's not used as frequently, but it's important for understanding orientation, especially in abdominal and pelvic imaging. So here's a problem that sonographers generally deal with. So during an ultrasound, an organ is measured in three planes: sagittal, top to bottom, 9 centimeters, transverse, side to side, 5 centimeters, and coronal, front to back, 4 centimeters. So assume the organ is roughly ellipsoid in shape. A, B, and C are semi-axis, which is half of each measurement. So the formula you use is 4/3 pi times A times B times C. So A is 4.5, B equals 2.5, and C equals 2. And you plug those in to your formula and you get 94.25 centimeters cubed. So when a sonographer rotates the probe 90 degrees, the plane switches from sagittal to transverse, and this is literally a geometric transformation, and sonographers must mentally track this in 3D space. So ultrasounds only show a single 2D image at a time, and sonographers use geometry to mentally rebuild a 3D structure from multiple 2D slices, and it's just like stacking slices of bread to imagine the whole loaf. So here's another problem that they have to deal with. You have 2D slices, and to make a 3D image 10 millimeters thick, how many slices do you need? So you take the number of slices equals the slice thickness, and the total thickness is 10 millimeters divided by 2 millimeters equals 5. So understanding planes and spatial geometry is what allows sonographers to get accurate images, and if your plane is off, then your measurement or diagnosis can be wrong, and geometry directly impacts patient results. This goes far beyond what we have learned in class because it involves 3D visualization, plane transformations, and interpreting moving anatomy through geometric slices. So for my learning aid, I did a game, and it's just called Sonography Plane Challenge, and so you just basically answer some questions. So the first one I have is a scan shows the body sliced left to right, dividing it into upper and lower portions. Which plane is this? The answer is transverse. Question 2, you rotate the probe 90 degrees from a sagittal image. Which plane is this? Transverse. Question 3, a single thin image slice is known as a 2D image. Question 4, if the probe marker points toward the patient's head, what plane are you scanning in most of the time? Sagittal, also known as longitudinal. Question 5, what plane divides the body into front and back? Coronal. And question 6, You have 2D slices every 1.5 millimeters. To make a 3D image 12 millimeters thick, how many slices do you need? The answer is 8. So this learning aid helps because it gives probe orientation awareness, measurement practice, interactive engagement, and error correction. So a little more deeper into those. For number 1, it shows how probe changes angles, affecting the sum and changes the orientation. 2, the learner takes the measurements of an organ, putting it in an equation, connecting geometry to real anatomy. And 3, it allows the learner to participate by answering questions, which helps memory and understanding the planes better than just reading a definition. And 4, while the learner has the ability to answer a question, they can also reveal the answers so that they know if they're correct or not, and this helps strengthen comprehension. So the tools I used was ChatGPT, and I said, here is the info for my sonography slideshow that I need a learning aid game for: sagittal, transverse, and coronal planes, how probe orientation changes the plane, 2D slices versus 3D volume images, geometry concepts like angles, spatial relationships, and measurements, and I told it to make a simple interactive game I can put in my presentation using this information. In conclusion, sonography depends heavily on geometric planes and 3D spatial reasoning. Understanding these concepts makes ultrasound imaging more accurate and effective. And that's how sonography relates to geometry.